Good evening, everyone. Thank you all for joining us today. Myself, Chaitanya, and I currently serve as DevSecOps lead at PepsiCo. Here, I'm responsible for designing and architecting solutions for CI/CD, automation, and operational processes within our containerization platform. I bring an extensive experience in cloud technologies, containerization, and IAC automation. My focus is on driving continuous improvement and innovation as part of our digital evolution journey. So joining me is today my colleague Prasanti.
Hi, I'm Prasanti. I currently serve as a containerization and DevOps engineer at PepsiCo. I specialize in Kubernetes cluster management and ensuring higher availability and security of the containerized workloads. My focus is into creating efficient and automated workflows to deploy apps to Kubernetes. And my responsibilities also include monitoring, troubleshooting, and continuously improving the efficiency and deployment speeds.
Today, we are here to discuss about how we accelerated the deployments at PepsiCo by implementing self-service continuous delivery, leveraging the GitOps framework and Helm charts. Before we move into the session, we would like to understand how many of you are familiar with this topic. Please raise your hands if you're using GitOps as a deployment strategy across your organization or company. Thank you. The next question is, how many of you are using App of Apps pattern? Thank you. Well, we hope you will find our session helpful, whether you have started your GitOps journey recently or you have been on it for a while. So today we'll start with a brief introduction about PepsiCo, followed by an overview of our cloud journey, sharing our experiences along the way. Next, we'll be discussing about our approach, our implementation journey, highlighting the key initiatives that we have rolled out. We'll then dwell into the GitOps workflow, followed by the demo. After that, we'll be discussing about the benefits that we have realized, what we hope to accomplish in the near future, and our lessons learned to help you avoid making similar mistakes. Finally, we'll open the floor for Q&A session. With about $86 billion net revenue and approximately 318,000 employees, PepsiCo is one among the largest convenient food and beverages companies in the world. Our convenient food and beverages are being consumed 1 billion times each day around the world. Many iconic brands are included in our portfolio, such as Lay's, Doritos, Cheetos, Pepsi, SodaStream, and many more. While each one of them would generate $1 billion each every year in the retail sales. We are part of strategy and transformation teams at PepsiCo. Strategy and transformation teams comes together to create brand new solutions to solve complex global business challenges and disrupt the norm. S&T includes strategy, change management, process excellence, value realization, digital, and technology. While we all work towards common platform and capabilities to leverage large-scale benefits, we are also responsible for developing the talent and driving agile ways of working. S&T embraces innovation and promotes a culture of continuous development of people and technology as part of our digital evolution journey. 7 years ago at PepsiCo, we embarked our cloud journey, recognizing the pressing need for the transformative approach how we develop and deploy the applications. As we navigated through this path, we discovered that the containerization is the cornerstone for our strategy. Containerization has provided several key benefits to the application teams. It has provided the scalable and consistent environments, which is crucial for the operational efficiency. It also improved the deployment frequency, enabling the applications team to deliver the new features and capabilities more quickly to the end users. Additionally, adopting containerization has allowed us to embrace new innovative architectures such as microservices, deploying machine learning models, IoT edge applications, and so on. This shift has fundamentally transformed the way how we build and manage our software, making our systems more reliable and robust. By leveraging containerization, we have not only improved our operational efficiency, but also increased the agility and responsiveness in today's fast-paced digital world. Here are the few opportunities that were emerged as part of our cloud journey. Throughout our journey, we recognize the need for establishing effective governance measures and streamlining our audit and control processes. We wanted to ensure all our compliance issues were addressed. The other significant outcome was our rapid growth. Currently, we have around 3,000 applications being deployed and 20K containers being managed across different environments. And 2,000 more applications are being onboarded in the coming year. Managing this scale is not a small feat. This rapid growth has resulted in high operational demand. We have seen around 2,000 ServiceNow tickets has been raised by the application teams, indicating the need for the improvement in various areas. To manage this, we have a dedicated operations team supporting them 24/7. We also identified the need for improving our operational workflows and monitor our increasing operational costs. The other significant aspect is to advance the Kubernetes knowledge within the application teams to enable them to fully leverage our platform capabilities. These opportunities and insights has shaped our approach. Our primary goal here is to create a single unified platform that centralizes the application source code, infrastructure as code, and our platform configurations, and provides self-service capabilities. Our initiative was designed in such a way to enhance our operational efficiency, improve the developer experience, and ensure the integrity of our applications. Here are the few key components of our approach. Firstly, we prioritize developer-friendly interface. This improves the usability and foster collaboration among the teams. By automating the repetitive tasks, we want to streamline our processes, reduce the manual errors, and free up some of the team's time to focus on the strategic initiatives. Real-time monitoring and alerting provides a visibility into our platforms and applications, enabling the teams to quickly identify and address the issues. We also want to establish self-correction capabilities as part of our platform so that few of the issues can be addressed automatically, thereby improving our performance and reliability. We also want to establish standard version control systems to manage the changes effectively, to have the clear history of the changes that are done to our code and configurations. We also want to create comprehensive audit trails to ensure accountability and facilitate compliance against regulatory standards. We aim to implement robust policy enforcements across our platforms and version control systems to ensure that we are adhering to our security and compliance standards. Now let us dwell into the key initiatives that we have rolled out to realize our approach. Firstly, we established standardized CI/CD templates. This move enhanced the efficiency and consistency as part of our development processes, enabling the teams to work more cohesively and reduce the potential for errors. Next, we have integrated security scans as part of our workflows to enable the application teams to quickly identify the issues at the early stages and making sure that they are adhering to our security standards. We also implemented OPA policies. OPA policies enforce compliance and security standards across our platforms. This helps us to ensure that the applications being deployed to our Kubernetes environments are adhering to our standards. We also created and started utilizing Helm charts for streamlining the application packaging and deployment into our Kubernetes environments. This helps us to facilitate the easier management of application in our Kubernetes environments. KEDA allows Kubernetes to scale based on external events, metrics, or custom signals, rather than just by leveraging CPU or memory usage. It helps us to build more resilient, cost-effective solutions in our Kubernetes environments. Finally, we embraced GitOps practices using ArgoCD. This allowed us to manage application deployments more effectively while ensuring version control. With GitOps, we could achieve more reliability and transparency into our deployments. Now I will hand it over to Prasanti to walk us through the rest of the presentation. Thank you.
Thank you, Chaitanya. Now let us go through the GitOps workflow with ArgoCD. By implementing the GitOps framework, the application definition and configuration are all declaratively maintained in a Git repository. We also have a GitOps agent running on the Kubernetes cluster, which continuously polls this repo for reconciliation of the cluster state. Although there are many available tools in the market, we have chosen ArgoCD as a tool of choice because of its stability, larger customer base, and intuitive UI, which is developer-friendly. By following this GitOps methodology, the application teams can gain greater control and consistency across the environments in their software delivery process. So now let us see the CI/CD workflow with ArgoCD in play for application deployments. Here we have two Git repositories, one for the source code and the other for the configuration management. We also have ArgoCD installed on the cluster, which continuously polls our config repo, aiding to the application deployments to Kubernetes. With the change in the source code, The CI pipeline is automatically triggered, which builds the source code and also creates a container image, which is pushed to the container registry. The pipeline here is also responsible in modifying the image tag on the config repo. And with ArgoCD continuously polling this repo, it immediately detects this drift and reconciles the application state on the Kubernetes cluster with the newly built image tag. Now, let us see a short demo. So this demo is to showcase how GitOps workflow has been implemented at PepsiCo and serviced as a self-serviced offering for application deployments. Here, the continuous integration is configured in an Azure DevOps pipeline, while continuous delivery is managed by ArgoCD. With a change in the source code, the pipeline does the following steps. It initially checks out the code repository, and then it also does a code build. With the successful build of the source code, it also runs a bunch of scans. It initially does a Sonar Cube code analysis in order to analyze the code quality and coverage, and then does a 45 SAS scan in order to identify the vulnerabilities in the source code and the binaries, and then does a SNCC SCA scan, which identifies the vulnerabilities in the open source packages used, and finally the SBOM scan to draft a full dependency graph and identify the vulnerabilities in the hierarchy and also deprecated packages. In case of any vulnerabilities identified in any of the above scans, the pipeline is aborted and the pipeline is failed. With the successful scan, it moves forward and builds a container image, which is pushed to the container registry, and then does a SNCC container scan in order to identify the vulnerabilities in the above built image. With this, the CI is complete, and now let us see the CD process. In order to streamline the deployment process, we have created a Helm chart, which allows the application teams to create all the necessary Kubernetes resources for their application deployment. So essentially, the config repo which we were talking about earlier would comprise of a Helm values file, which aids to their application deployments. And with continuous delivery using ArgoCD, the pipeline here itself would do the modification of the image tag in the config repo, while the deployment alone is taken care by ArgoCD. So let us see how it is done here. So the pipeline here initially checks out the config repo and then pulls the Helm chart from the registry, and then it generates the Helm template out of the pulled Helm chart and the values file from the config repo. It then does a SNCC IAC scan in order to identify the vulnerabilities in the configurations used. And in case of any high vulnerabilities identified, the deployment is aborted and pipeline is failed. With a successful scan, the pipeline goes ahead and modifies the image tag through a PR, which is auto-closed with in a lower environment, while in a higher environment like pre-prod and prod, the PR is left open for the team to review and complete. Now, let us see how the deployment is taken care in ArgoCD. In ArgoCD, we have followed app of app pattern instead of application set to provide greater flexibility to the teams to override a source or a sync policy at a child applications. And here we are creating a bootstrapper application which continuously polls a config repo. And such a bootstrapper is created per environment and destination cluster. So here, as you see, all the applications to be deployed are maintained with their Helm values files in it, and the application definitions are maintained in Argo app configs.yaml. So here, I would like to take a moment and pause the demo here to mention that this is the repository is being modified with the latest build image tag by the pipeline we saw earlier. And it is also worth mentioning that the bootstrapper which we saw earlier is backed up by a Helm chart, which is programmed to read through the configurations here. These are all the Argo app configurations which we mentioned, and creates the child applications for us. Now, let's resume the demo. So essentially, in order to onboard any new applications, all the developer needs to do is create such a folder, place the Helm values, and add the Argo app config to appconfigs.yaml. So let us see how it is done. Here, we are creating a demo app called JetSet with an appropriate Helm values file to it. And for the sake of demo, all these changes are being done directly here. But Essentially, such a repo would have the branch policies to allow all the changes only through a PR. Having added the Helm values, all we need to do is to add the Argo app configuration to ArgoCD appconfigs.yaml here, with which the bootstrapper would potentially identify the onboarding of this new app and creates the app and the associated Kubernetes resources within the reconciliation window. So for the sake of demo and in the interest of time, let us go and do a manual refresh on the bootstrapper app from ArgoCD UI. So whenever we do a refresh on an app from Argo UI, it basically pulls the latest commits on the monitored repo. And as you see, it could detect the onboarding of JetSet app, and it has created it. And we also see that it is turned green, meaning the application state is now in sync with the repo state. So if we go and monitor the application in Argo UI, you should be able to see all the Kubernetes resources required for the application deployment are created. So in this way, by combining the app of app pattern with Helm chart, we could build a robust framework which could be self-serviced for application deployments. So now let us go through the benefits which we have realized by implementing such a framework. In the early days of our containerization journey, the application teams were allowed to create only a deployment and service objects through the pipelines, because we basically use a multi-tenancy model in many of our clusters. But with the adoption of ArgoCD and Helm charts through our GitOps workflow, now the application teams are able to create all the necessary objects by themselves. And this has reduced the dependency on the operation team, as they were able, the operations teams were creating all the other Kubernetes objects for them earlier, but now that they could create everything by themselves, app teams no longer have that dependency on the operations team. This has reduced the number of ServiceNow tickets served by our operations by 50%. With this implementation in place, we could reduce the time to deploy an application by 25%. Not only time to deploy, but we could also onboard new applications much faster because of the app of app pattern we use. By streamlining the GitOps workflow and by reducing the manual intervention, we could improve the deployment frequency to a great extent. And with clear application state available from the ArgoCD UI and easier troubleshooting available there, we could also reduce the mean time to recovery to a great extent, which in turn improved our system reliability and application team's performance. So moving on, now we would like to share what are all the items we would like to work in the near future in continuation to our GitOps journey. Currently, we are leveraging ArgoCD for application teams deployments alone. But going forward, we would like to onboard all our platform components to ArgoCD so as to ensure faster and easier installations and upgrades on the tools we install on Kubernetes. We are also planning to implement a DR strategy for ArgoCD so as to ensure minimal disruption for application deployments in case of any outage. Currently, application teams are leveraging feature flagging to enable controlled rollout of any new features they develop. Going forward, we would like to add various deployment models like A/B testing, blue, green, canary, etc., along with feature flaggings to give greater flexibility and reduce errors. As we operate at scale, we would like to ensure ArgoCD would meet our growing demands, and while rendering a reliable and responsive UI for application deployments. So we would like to evaluate ArgoCD under various load conditions by pushing its limits and watching out for bottlenecks, and identify the necessary configuration for our scalability requirements. Developer Portal is a single-stop provisioning solution for all the developers. The intention here is to simplify the project onboarding process by provisioning all the necessary infrastructure, tools, and CI/CD workflows all within a single request. Finally, we are also working on creating a Grafana dashboard for ArgoCD metrics, which allows us to monitor its performance. This also provides a comprehensive visibility of the health of all our apps and the deployment trends in real time. Now, we would like to share our valuable lessons learned throughout our containerization journey. With the implementation of any new methodology, it is beneficial to start small as it allows enough room for improvement. The GitOps framework with ArgoCD and Helm was initially evaluated with fewer teams for usability before rolling out to all. So this has allowed us to mitigate the risks and allowed for a smoother transition towards a fully realized GitOps workflow. As we integrate multiple tools and systems within our DevOps process, a single security flaw in a tool can potentially compromise the entire system. Hence, having robust security practices in place would essentially allow us to mitigate such risks or vulnerabilities. By clearly defining the processes and a thorough documentation, we could improve the team's efficiency and reduce errors while achieving a greater reliability and a scalable DevOps process. Adaptability is a fundamental principle that results for effectiveness in DevOps. An adaptable DevOps process can help teams to pivot quickly to the changing market needs and business conditions. It also helps teams to stay agile and foster innovation and continuously improve their processes, which are all essential for success in a dynamic environment. By including both monitoring and observability into our practices, we could improve the system's reliability and improve our incident response time. And by emphasizing both training and knowledge sharing, we could build a strong DevOps culture which drives collaboration, innovation, and continuous improvement, all leading to better outcomes. And finally, by systematically gathering the feedback from the teams and acting upon them, we could meet our business needs much efficiently. With this, we would like to conclude our presentation and open the floor for Q&A. Yes, please.
Thank you.
Hello. Thank you for the session. So we are in Porter. So we are coming from Porter only, myself, Bijoy. So we are using similar kind of architecture. There are also app of apps. So we are right now, there are two things we have not able to solve yet. So first of all, like the app of apps. But the main application which create the other application, how we are managing the GitOps of that? So that is my first question. And second question, the changes in the ArgoCD tool itself. How we are managing that also?
Sorry, the question was not clear. Can you please repeat?
Yeah. So the first question is the main application, ArgoCD application, which creates the other application, the app of apps. How we are managing changes of that main application, right? Or how we are creating that main application.
Yeah. So we would be ideally onboarding the projects by creating a bootstrapper as a platform team, wherein the application teams will be responsible in creating the child apps alone. That's how we are managing today.
So I'm saying you are using some other IC tool to create the main application, or?
So currently the main application creation is manual. So we were talking about the developer portal, right? So we are automating the onboarding process also using Ansible to create that bootstrapper, the main bootstrapper application also.
And my next question is the changes in the ArgoCD tool itself.
The upgrades.
Let's say changes in the ArgoCD CPU memory or anything, any config level changes or rollback changes in ArgoCD. Yeah. So how we are applying those changes?
Yeah. So currently the installation and upgrades are all manual today, but we are also automating that as part of the developer portal we were mentioning, right? Okay.
And we have Terraform pipelines with Ansible, where we have the cluster creation and the add-ons being deployed. So ArgoCD installation is part of that. Okay, so that's how we have solved that issue.
Okay. Thank you.
Yeah.
Any other questions?
Yeah, I think there's.
Hi.
You can please come here.
Have you guys considered application sets, and why did you go with app of apps instead of application sets?
Yeah, that was not, I mean, we did explore application sets, but that was not meeting to most of our requirements, as I mentioned, right, to override a source. Let us say, for example, we are trying to deploy a COTS application. There, I should be able to override the Helm chart version and all. When it comes to in-house applications which we build, we have created a Helm chart for ourselves, which we need to able to leverage that, right? So such scenarios we could not meet with an application set. That's the reason we went ahead with the app of app pattern.
Could you please talk in the mic, please?
Do you consider using customize for overriding things in the
Yeah,
application?
we did,
sets?
but
What
we
was
were
the
not able
challenges?
to override the source as such at a child app level.
Okay.
Yeah.
Thank you.
Hi. In your example, you showed that you were changing the values YAML. That was changing the Helm chart, I'm assuming. So does app team manages the Helm chart, or it's all managed by ArgoCD?
Platform team manages the Helm charts. The only thing they have to take care is to update the Helm values file.
Okay.
Yeah.
So you have one version of Helm chart that
Yeah, Helm charts, yeah.
that platform team
Yeah,
manages, and
platform team
everyone,
manages. Yeah.
every app team uses the same Helm
Yes,
chart.
yes.
Okay.
So with all our platform standards, we have created that Helm chart.
Right. And the follow-up question on that one then, does that Helm chart then gets into Git where app team looks at it, or it's completely...
Yeah, currently we maintain in the container registries, the
Okay.
Helm charts, yeah.
Okay, got it. Thanks.
Welcome.
Hi. So how the rollbacks was maintaining with this ArgoCD model? How the rollback is happening?
Yeah, currently the rollbacks we are supporting are only from the repository, not from the UI, because all of our applications are multi-sourced, right? One being the Helm chart and the other being the config repo with the Helm values. So for a multi-sourced app, we will not be able to roll back from the UI. Essentially, it is done from a repo.
So what I'm asking is that we are committing the image tag so that it was updating the deployment. So if something goes wrong, so how we are taking that back to previous version?
Yeah, we want the teams to revert based on the history of the Git, right? So revert back to the previous version so that they have that up and running. So currently the rollback is maintained that way.
Okay. Thank you.
Yeah.
Yeah, hi. I want to ask, apart from this, I want to move my databases into Kubernetes. So is it a good idea, or if I move them on Kubernetes cluster, so what thing I keep on mind and how I achieve that with a high HA?
Yeah, primarily Kubernetes is designed for the stateless applications, right? If you want to have the stateful applications to be running on the Kubernetes, you should have your backup and strategy, right, to be defined actually. So if you have that defined properly, I think you can go ahead, but it's not a recommended solution to use Kubernetes.
But actually there are some Helm charts or other providers do like that things. So that's why I curious about that.
Yeah, we also explored Azure backup and restore mechanisms, and they were at the preliminary stages. They are not up to the mark to have the stateful applications being deployed currently in the Kubernetes environment, is what our understanding as of now, yeah.
Okay. In future, is it possible handling that databases?
Yeah, definitely if we have the robust solutions available, right, yeah.
Okay, thank you.
Thanks.
Yeah, please.
Yeah, she's waiting for so long.
Hey, thanks for such a detailed session, and
Thank
it was
you.
structured very well. Thank you for that. So we also have a lot of applications getting deployed, and we use application set. I understand that you said you explored application sets and also decided to go for app of apps.
Yes.
So what version of ArgoCD are we talking about?
It's 1.27. 1.27.
I think now we are at 2.13, right?
Yeah, you're telling about Kubernetes version.
so
Yeah,
no, I'm talking
it's-
about ArgoCD version.
Yeah, it is.
It's the latest version, 2.13, I think.
2.13.
Yeah.
So most of what you've mentioned as the drawbacks of application set can really be done with application set, right?
See, we wanted to make it as a self-service offering, as in the app team should be able to override whatever they want, as in the sync policy or a sync wave or a source, any of such things, right?
Okay.
So when we explored that by exposing a Helm chart, as you have seen, right, we wanted to give a values file where they can configure things and should be able to deploy child apps as per their needs. When we did that, we were not able to override some of the configurations, like a source especially. Like we also tried using customize along with Helm chart to override certain things, but yeah, we couldn't do that.
So is your configuration of apps static, or is it dynamically, can you dynamically generate?
I'm sorry, as in
Is your list of applications always fixed?
no.
No. So how
That
do you
list can
dynamically
grow.
generate app of apps?
That's what, it's a Helm chart again, backed by Helm chart, which loops through your ArgoCD applications list there.
Okay.
Which internally creates
So
Argo
your
apps.
manifest has to be checked in of the application.
Yeah, this particular ArgoCD app configs.yaml, which I've shown, right, that is checked in.
Okay.
And the bootstrapper which we create would ideally have Helm chart, which I mentioned, is a source one, and source two being this YAML. Okay,
Got
so it loops through that list, creates the applications as a child applications as per the configuration you give. So it takes the source, sync policy, whatever you want, you can configure there, and they'll be able to deploy their apps.
Got it. Okay. And coming to your DR, I saw that in your future plan. Have you made any progress so far on DR? Because we are doing something similar. So
Okay. So yeah, we were trying out with the next, because most of the repositories and are all created as a secrets, right? Yeah, we are planning to go with backup and restore mechanism that makes the secrets creation and all faster. Although we have all the configurations of ArgoCD, for the installation and all maintained in the repo, the secrets are always missing, correct? So that's how we are planning on. We are making our trials.
So right now your cluster onboarding to ArgoCD, repository onboarding to ArgoCD is all manual?
No, we have automated that recently.
Okay.
Along with the cluster creation, the post-provisioning pipeline does the installation of Argo and the creation of the main bootstrapper and all of that. The application onboarding, the project onboarding alone is done manually today, but we are planning to automate that as well.
Sure. Thank you.
Thank you so much for your presentation. So I have a quick question. Like you saw, show that you are managing around 3,000 something applications via ArgoCD. So we see like when we are doing it in our organization, there is a performance impact on ArgoCD where the UI takes a lot of time to load, etc. So whenever we are having application set and app of app, so this makes a kind of pressure on ArgoCD. So do you face this similar issue? And if yes, like how you resolved it?
Yeah, we are currently doing that performance testing and all to ensure that we don't end up in that state. But as we have mentioned in the slide, right, like around 70% of them are onboarded to Argo. Not all applications are today managed by Argo, but we are in that journey to make onboarded everything to ArgoCD.
Okay,
And
thank you so much.
currently we have multiple instances of Argo being running based on the different sub-business units that we have, right? We don't have a single giant ArgoCD instance managing. So we have logically segregated that to overcome these performance issues.
That makes sense because for us it's a single Argo which is
Yeah.
managing also.
Yeah.
Thank you.
Thanks.
Any other questions or? So to connect with us, outside the session, kindly scan the LinkedIn QR codes here. Thank you.
Thank you all.